Zero.
Hi, everyone. Thanks for joining us again on Easter Sunday. I decided to go back and do what was actually originally Ken Shoulders number 37. And we actually had Moray King in the group back then. And this one is it's from Ryan Wood's UFO AI index, if you want to call it that. But it's an AI system that's set up that isn't on the internet. Basically, it's a closed system essentially. So I asked some questions of it, and it came back with some really cool answers. And when I read through it, I decided to maybe just go through and go through it again.
So what we're talking about, Ed, is essentially the Woods have used this document in the specialty training for their AI system, correct?
Yeah, well, basically, I asked because I've done this a number of times with Ryan. I've asked certain questions of his setup
Right.
to draw information out, and but also remembering too that we've fed a lot of information back in there. Like for example, my 80 pages of subquantum kinetics from Paul is in there. There's a lot of Etheron stuff specifically in there. There's a lot of charge cluster stuff from Ken Shoulders because I actually gave Ryan Wood all the stuff that we're going through in Ken Shoulders, number 58 now. Ryan has all that stuff in this setup already, so it's drawing out of there, but it's not connected to the internet. So it's actually not the kind of AI that everyone kind of thinks about. It's like a closed loop setup, or our own private AI, if you want to call it that, or whatever. And just very beneficial and very thankful. We had Dr. Ryan Wood in the group. It was number Ken Shoulders number 35. And just for those that don't know who he is, he's the son of Dr. Robert Wood. And Dr. Robert Wood was the main editor of William Tompkins' books called Selected by Extraterrestrials. And I used to talk to, he's passed away now, but I used to talk to Dr. Robert Wood on the phone and about William Tompkins and about some of this stuff. And I can actually remember him. I sent him my 80 pages of notes from Paul and some stuff on Stevati Aerospace and a whole bunch of stuff in a hard copy. And when he got it, he was ecstatically happy to have it. So it was kind of cool. And yeah, he's since passed away, but Brian is his son. And Ryan has kind of taken over for his father with a lot of things. Maybe not selected by extraterrestrials, though. I think Dr. Sala is going to be the main editor because there is a fourth book that most people don't know about. And Dr. Robert Wood told me that there was a fourth book in the works on that, and it'll be the final book of Tompkins at some point here. So cool. So yeah, let's get to it.
All right, so we just want to read through this email thread, right?
Yep.
It's dated 7th of September, 2025. Uh, from Ed, and a question to AI ufologists, and I assume that's the Woods database, right? Their AI.
Yeah.
Yeah. All
Yeah.
right. Can you tell me about charge clusters and how it relates to all these technologies? Number two, can you explain etherons? Are they toroidal? Number three, can you tell me about how exactly we can tap into the ether and use charge clusters to gain free energy? All
Good.
right.
Good questions,
Then,
right?
yeah, very to the point. And there's a reply back here powered by Elementor. I guess that's the name of their AI. We go down a little bit to the next page
Yep.
and see what kind of an answer Ryan Wood returns. AI UFO DEX query request. All right, here you go, Ed. Looks like a strong response. Cheers, Ryan. Highlighted UFO analysis AI, colon. Certainly, your question touches some of the most profound and promising areas of advanced energy research, connecting and pioneering work of Ken Shoulders on charge clusters, the electrum validium or EVs, the concept of the ether or ether, either spelled with an E or an A, and their relationship to both free energy technologies and the propulsion systems reported in UFO and UAP phenomena. I will provide comprehensive, technically detailed, and referenced answer drawing from the extensive literature, experimental evidence available. Okay, number one, what are charge clusters? Charge clusters and Ken Shoulders' work, all related to that. Charge clusters, as discovered and developed by Kenneth R. Shoulders, are micron-sized, highly organized aggregates of electrons, sometimes ions, that exhibit remarkable stability and energy density. Shoulders calls these entities electron-volitum, EVs, meaning strong charge. Typical EV contains on the order of 10 to the 11th electrons, can also carry positive ions, heavy ions usually, as I recall, forming a quasi-neutral but highly energetic plasmoid. So it is a plasmoid. Very interesting. All right. Yep. The size, the key properties, size is about 1 micron in diameter. It's 10 to 11th electrons, sometimes about a million ions, 10 to the 6th. Velocity can travel up to 0.1 c, 10th the speed of light. Stability, remarkably stable. Able to bore holes through ceramics and metals without dispersing. Klingon disruptor.
Yeah.
Energy output. When striking an anode or passing through a coil, EVs can produce electrical pulses with more energy than was required to create them. Should I repeat that? Yeah. EVs can produce electrical pulses with more energy than was required to create them, suggesting an external energy source is being tapped.
The ether.
Yeah.
Periods, right?
Right. Next one. How are they created? EVs are typically generated by applying sharp high voltage pulse to a pointed cathode in contact with a dielectric positioned above a plate anode. The abrupt discharge causes a microexplosion at the cathode tip, launching a compact, negatively charged plasmoid, the EV itself, across the gap. All right. Shoulders has measured that the 1 micron diameter EV contains approximately 10 to the 11th electrons and 10 to the 6th ions. When launched, it typically travels at a velocity around 1/10 the speed of light. Shoulders shown that when an EV strikes an anode, it produces an electrical pulse, which contains more energy than it took to create it. All right, reference there to charge clusters from Moray King in his book, The Basis of Zero-Point Energy Inventions. All right, number 2, charge clusters, UFO, UAP, relationship to propulsion and energy systems of the UFOs. All right, many advanced propulsion concepts reported in UFO literature, such as field propulsion, inertia modification, and anti-gravity, are consistent with the properties of charge clusters and their interaction with the vacuum or ether. Okay, plasmoid propulsion. Definition: the rapid coherent movement of charge clusters, plasmoids, can create local distortions in the vacuum, potentially reducing inertia or gravitational coupling. See T. Thompson Brown's electrogravitics and Byfield-Brown effect in parentheses. Energy extraction. The over-unity energy output observed in EV experiments suggests that these clusters may be tapping into the zero-point energy of the vacuum, a concept central to many free energy and UFO propulsion claims. Toroidal structures. Many UFOs are described as having toroidal, donut-shaped energy fields or plasma sheaths. Theoretical models, as in Ledbetter's Anu and Ekmov's Phaeton and King's dual vortex forms, propose that toroidal, counter-rotating vortices in the ether or vacuum are the basis for both charge and mass.
Counter-rotating being the key there, I think.
Yeah.
From Pavel's work, big time.
All right, continuing. Discovery of macroscopic quasi-charged formation appears to have already been made by Shoulders. An abrupt electric discharge from a pointed cathode near a dielectric surface creates a micron-sized plasmoid with a net equivalent charge on the order of 10 to the 23rd 20 to 23 electrons. Shoulders named this charge formation electrovolitum, EV. Again, reference to Moray King. Next
Mhm.
question, what are etherons?
I might
This
I
is,
might interrupt because the number 10 to 23rd was an error. That's Avogadro's
Oh,
number. That exponent was an error in my work.
okay, cool. And I think you said that
It's back.
last time we did this. Yeah.
Yeah, it's back to 10 to 11th, like we said
yeah,
earlier.
I
Okay.
was going to say, where did that come from? That's interesting.
From
Other than the fact
chemistry.
it's, yeah, it's a prime
Brainwashed in
number.
chemistry from all the chemistry courses I took.
If if
Just
you're
spilled out of me.
if you're not sure what the number is, just make it prime, right? It becomes a big
When you're
mystery.
doing
That's funny.
the 16 and 18-year-olds exams, it's a typographical error is kind of like impossible because you just believe finding
Yeah.
a typographical error in the textbook, it seems impossible. How can it be wrong? When you get to
Yeah,
PhD level, you have to deal with typographical errors all the time.
this wasn't even a typo; it was a brain fart.
That's awesome, right?
I love your honesty, Mike.
Exactly. That's awesome.
It was my bad. I couldn't believe I missed
My
it on the
bad.
proofreading.
Yeah. And
All right.
there's the author fessing up basically.
Yeah, and sorry about that. If you find your EVs too powerful and they blow everything up, you can blame that on me.
There you go. I like it. Hmm.
All right, the next question relative to etherons. Etherons and ether, are they toroidal? Etherons is a term sometimes used to describe the fundamental units or quanta of the ether, a hypothetical, all-pervading medium that underlies physical reality and is a substrate for electromagnetic and gravitational phenomena.
Hmm.
The Jesus particles. All right. Toroidal nature. Ledbetter's Anu in occult chemistry. Ledbetter and Besant describe the fundamental building blocks of matter as dual vortex toroidal forms in the ether, kissing pine cones, according to Dan Winter, with
Yeah.
opposite chiralities corresponding to positive and negative charges. Left-handed and right-handed universe. All right. Akimov's phaeton, Russian torsion field theory models the vacuum as a lattice of Planck's scale counter-rotating toroidal entities, phaetons, whose polarization gives rise to electric, gravitational, and torsion fields. King's dual vortex model proposes that the vacuum's zero-point energy can self-organize into vortical forms at any scale, with charge polarity determined by the chirality, handedness of the vortex. I've concluded fractality in that. Any scale. All right. Ledbetter suggested the positive charge circulation twists blocks from a fourth dimension in our three space to become a source, while the negative charge circulation induces a corresponding sink. The illustration shows centripetal inner vortex surrounded by an outer circulation connected by a Mobius twist.
That's really important, the Mobius part.
Centripetal inner vortex, surrounded by compressive implosion, surrounded by an outer circulation, connected by a Mobius twist. Self-regulating, self-assembling, self-stabilizing. The Mobius that is important, Ed.
Yep.
Okay. How to tap the ether using charge clusters for free energy. Theoretical basis, 0-point ZPE in the ether, quantum vacuum definition. Modern physics recognizes the empty space is filled with fluctuating electromagnetic fields, the 0-point energy. Ether as ZPE. Many researchers equate the ether with a quantum vacuum, suggesting that it is a dynamic energetic medium that can be cohered and tapped under the right conditions. Going on to the next page, mechanism of energy extraction. Abrupt nonlinear motion. According to Prigoghine's theory of self-organization, a system far from equilibrium, as in a plasma undergoing abrupt discharge, can evolve into a coherent state, drawing energy from the vacuum in the process. Charge cluster as a vacuum pump. The EV acts as a vacuum energy pump, cohering the ZP as it moves and releasing the excess energy when it interacts with matter, as it's striking an anode or passing through a coil. Shoulders and Puthoff suggest that the excess energy is from the zero-point field. Messiatz shows that the ecton is launched as a result of an explosive emission from the cathode tip. Shoulders uses liquid metal, as in mercury, to maintain the tip and thus keep it a source for repeatable launching.
So is that the first time the word ecton was used?
It's the first time I remember it.
Yeah, right. Because Messiatz he was a vice president of Russian Academy of Science. He loved Ken Shoulders' work.
Yep.
And he was kind of taking credit for himself, and Ken laughed because it was even lifting his diagrams right out of the patent. But Ken didn't care, just so he's on board. That was what was important, right? Ken didn't care about the credit. So he coined that word. Messiatz made up that word to explain the entity, name the entity instead of EV or EVO. He called
it an ecton.
And then if that appears in the Russian work, that's the history of where that name came from.
Yeah, huh. That's cool.
The only thing I can relate that to is Ghostbusters, ectoplasma.
Oh, that's a good point, actually.
That's maybe yeah. So anyway,
that's a good tip, because just remember who you're gonna call.
Oh God! All right. All right, so these are all comments from Moray's book, 1997, the basis of 0-point energy inventions. All right.
Is this an AI? Is this AI generated? This monograph?
Yes, it's you were one of the sources in the training for the AI. All right, so number.
Oh, I love corrupting AI.
Yeah, I think I fed Brian some of the information. Yeah.
So this subheading is under practical steps for tapping the ether with. Number one, create a high voltage abrupt discharge system. Use a pointed cathode, possibly liquid metal, as a dielectric plate around the grounded anode. Apply a sharp high voltage pulse with launch EVs. Number two, guide and harness the EV.
I'll just stop you for 1 second there. It's very important to know that it's a negative voltage. Minus 2,000 volts is where they like to form.
Negative electricity, is that negative electricity as well? Is it?
Well, it's a negative voltage because you have positive or negative polarity, right? And they like to form under about minus 2,000 volts. Essentially, that's kind of their sweet spot.
Cold electricity. Is it?
Well, you could call it
that. Was normal. It was normal discharge off a capacitor. In fact, that's how he knew what his energy was, because it was 1/2 CV squared. Just use the standard electrical engineering capacitor energy stored in the capacitor. That's his input energy. All the rest is observing what that does once it launches an EVO, which was not mentioned in the text, because that was the alternative name that Shoulders came up with later.
Yep.
Once he was convinced, he wasn't convinced at first, didn't know where the energy came from. He wasn't ready to commit to later.
Yeah.
Once he was convinced he had way too much energy compared to what that capacitor had, then he said, "Okay, we'll say it comes from the vacuum energy," and then that's where the acronym EVO, exotic vacuum object, was coined. And it's a good thing too, because when you say EV, people think electric vehicle. Right. So.
Yeah, exactly. And it's interesting to know too that EVO, that's the name of John Hutchison's dog. EVO.
Well named.
I asked Nancy, John's wife, I said, why did you call him EVO? And she said, because that was the only name that he came to. So that's interesting, right?
He didn't know about Shoulders' work?
Oh, well, of course he did, because they were good friends, right? Yeah, but what John didn't know was the connection with Chris Beskar and Stavati Aerospace and Ken Shoulders and so on and so forth, right? Until we brought all that out to the public, essentially. Yeah.
All right, I have a question that we will continue with this, but at the end, I wanted to ask Moray something here about this specific last comments here. All right, so number two, guide and harness the EVs. Use a dielectric guide to shroud and direct the EVs and separate them from residual ions. Second point, surround the path with a coil or pickup circuit, bifilar, to capture the induced electrical impulses.
Mm-hmm.
Rectify and store the output. Use a pulse current multiplier or similar circuit to convert the high voltage short duration pulses into usable DC power. Important, I think, the DC. All right,
Yep.
store the energy in capacitors or batteries. Number 4, enhance the effect. Use a glow plasma at normal glow discharge to precondition the cathode and increase EV production. There's a patent on that from Korea. Experiment with counter-rotating magnetic or electric fields to induce dual vortex forms and maximize ZPE coherence.
Mm-hmm.
Yeah, a lot of auto manufacturers have been trying to tune their induction manifolds the very same way. All right, General Motors to boot. All right, so solid state approaches. Trap EVs in a dielectric, as in maybe cracked barium ferrite ceramic, sparky sweet, via fractal emission, as in sweet. Oh, there it is.
Yep.
As in sweets vacuum triode amplifier.
Mm-hmm.
All right, use bifilar pickup coils to extract the energy from the persistent EVs trapped in the material.
Mm.
And Sparky's barium ferrite ceramic actually rattles if you shake it because it's got powdered ferrite rattling around in the vacuities.
Interesting.
In fact, that's important.
It's very important. Yes.
The grains became loose inside.
Exactly.
And so now in your fractal emission, just imagine a grain particle spinning around in that crack. Right, it's tiny. It's on the scale of a micron. It's now undergoing a spin, and if you have a corresponding counter spin in on a different particle, they're next to each other, then you have your counter rotating vortex induced by those two spins of the particles. Now we don't know if that model's really happening, but that was occurring to me is when I wrote that paper for that conference. That would explain why a bifilar pickup would work. It's ready for the helicity of either direction.
There you go. That's very important, Murray.
Very interesting.
Right, but this I would class this as speculation, of course, because is all this really going on? I think we know that it's cracked. We know for sure it's cracked, and we know we can induce the fractal emission plasmoids in cracks. So we know that, but whether all this spin phenomena is occurring, that was basically an intuitive insight that flashed to me, at the time I was preparing that talk. So I thought I'd mention it. So that's kind of the history, the idea. So I would not class it as locked in reality yet. I would class it as a hypothesis.
But
I would totally.
I channel reality. I think therefore it's good, right?
There's some other loose associations though we could throw at it to get a little more comfortable with the fact that we can't experiment and see the Marfa lights in Texas, fractal emission. That's a theory that's been proposed for quite some time.
Right, earthquake lights. That's well known, and people observe the ball lightning coming out. So the history's there for the pattern to fit.
And it would sound as if the loose material is a nucleation effect. Okay, well, rain falls out of clouds for a very similar reason. So there's generalities we can draw and get comfortable with the overall concept. All right, so anyway, here's all.
Fractal means fracture, right? And it came from the Italian research studying the phenomena.
Yes.
In small crystals where they do crack them, and the energy persists for hours. So it's very anomalous.
Yeah.
Right, as was studied. So preparata, I think, is the name of the main preparata is the correct pronunciation. It was told.
Yes,
Italian
very interesting
researcher, and he was the lead guy, and it was his work that I was referencing to inspire me to say all this.
Oh, cool.
So here's a list of references: Ken Shoulders, Moray King, Correa Pudov, Messiet, Ledbetter, Akimov, and Sweet and Bearden.
Yeah, it's quite the list, isn't it?
Yeah. Classic bunch of excellent papers. All right, summary. Highlighted. Charge clusters, EVs are as discovered by Ken Shoulders, are micron-sized toroidal plasmoids that can tap into zero-point energy of the vacuum, the ether, when created and manipulated under the right conditions. These clusters are likely the basis for many advanced energy and propulsion technologies, including those observed in UFOs, UAP phenomena. Theoretical models suggest that the ether is composed of toroidal counter-rotating vortices, etherons, photons, or anu, and that by creating similar structures in the lab using abrupt nonlinear plasma discharges and dual vortex forms, we can cohere the ZPE and extract usable energy. This is the foundation for a new generation of free energy devices and may hold the key to advanced propulsion and environmental transformation.
Wow, that's quite the statement.
It's a rapidly evolving field, and I encourage you to consult the latest issues of Infinite Energy, Journal of New Energy, and the works of Moray, Big King, Ken Shoulders, and Hal Puthoff for ongoing developments. Stay tuned.
Yeah, and I take credit for hallucinating the AI to believe in Avogadro's number.
Yeah, I like it. That's funny.
That one.
All right, this is the second set. All right, so UFO analysis AI. This is the Ryan Wood's program. The concept of charged clusters and their potential role in UFO technologies, as well as their connection to the ether, is a fascinating topic that bridges the realms of advanced physics, speculative science, and the study of unidentified flying objects. Charged clusters highlighted are often regarded as electron-viridium and are micron-sized plasmoids that exhibit unique properties, potentially allowing them to interact with zero-point energy and other exotic energy sources. Let's delve into these concepts and explore how they might relate to UFO technologies in the ether. Charged clusters are essentially tightly packed groups of electrons and ions that form under specific conditions, such as during electric discharges or in plasma environments. These clusters can contain a net charge in the order of 10 to the 11th electrons and 10 to the 6th positive ions. As observed by researchers like Ken Shoulders, the stability of these clusters is often attributed to their helical vortex ring structure, which creates a toroidal magnetic field and traps the electrons and counteracts the Coulomb repulsion that would otherwise cause the cluster to disperse. Formation of charged clusters is typically associated with phenomena such as fractal emission. The cracking of materials like crystals or dielectrics leads to the emission of these charged plasmoids. This process is...
I might mention right on. Everybody was believing, I think it came from Hal Fox, that these were collections of electrons. But Ken and I were speculating there's something more fundamental going on. He completely agreed that we're actually manifesting the equivalent of a macroscopic charge, as opposed to having a collection of charges, because his experimental proof was he can make positive ones that had the same charge to mass ratio as the normal EV. Basically, it has a charge to mass ratio of the electron. In this case, it was a charge to mass ratio of the positron, but it is not a cluster of positrons. Because when they hit the target, you didn't get the gamma radiation that you would get from positron and electron annihilation at all.
Yeah,
it would get basically the same fault. And that, I said, that was your most important experiment. And he can even do pair production. I said, but that positive EV is proof there's something more fundamental going on than collecting charges. And that's what really puzzled Feynman. If this collection of charges, that repulsion should just blow this thing apart. It's impossible to do. So Ken and I agreed. You have hit the primary mechanism of how does the vacuum manifest charge at any scale. I called it macroscopic charge, and it was not a collection of small charges. Yeah. So that was really the most important point. And I think Hal Fox, who was a big Ken Shoulders fan back in the 90s and was the editor of Journal of New Energy, he called it charge clusters. So the name came from him and his literature, who really loved it. And that name stuck because he was the editor of Journal of New Energy and speaker at the conference. And so And so that's there we are. So the whole thing about macroscopic forms and counter-rotating vortexes, the counter-rotations, things like to come in pairs.
Yeah.
So we're manifesting from the vacuum. And he and Ken Shoulders did photograph two charge, two EVOs of opposite charge spiraling around each other, a pair
Yep.
production. He
Yep.
he created those things. So there's something way more fundamental going on than trying to collect charges and keep them packed together. And so a lot of people, that's where the big misunderstanding occurs, including Feynman, that just this can't exist, right?
Yep.
It's easy to do the calculation. The electric field's so powerful
Yeah.
that there's just no way to do it. But to make something from the vacuum that appears to be like a charge, I said you've hit the fundamental mechanism for the vacuum to manifest pair production. Right,
And
the electron positrons is the first level. Dirac came up with that back in the 30s.
yeah.
But there's something way more fundamental that you discovered, and he agreed. And that's
And
so there you go.
yeah, and there's a letter from Feynman to Ken Shoulders apologizing twice in that letter for not listening to what Ken had to say. Richard
Well,
Feynman, right?
it's it was pretty tough to. I think Feynman was right on the basic calculation. It can't be a collection charges. So Feynman was right on that point. What he missed was Ken discovered something experimentally, and what the heck is it? We don't know, right? And looking at the other hypothesis, we're making something out of the vacuum energy. But then it's a spectacular claim of the way the vacuum works, the way the ether works.
Yeah.
That this type of behavior manifests equivalent of charge, something that looks like charge at a large object. And so we're off and running to something new. I think Feynman apologized because he did recognize the experiment and that there's a big mystery here, and so he was just objecting to the idea of a collection.
Yeah. But he always did. Feynman was very harsh at pointing out the fallibility of a solar system model of the damn atom atomic structure. An electron is a probability fog. It's a cloud. And what happens when you merge or blend 10 to the 11th of them together? You still have a fog, which looks not like a point particle. It looks more like a wave or a field, which is really what it is. A unity field is what comes out of this. And it's not something you can blow apart with lasers or anything, which is concerning Feynman.
Yeah,
it's
something large. The other
Yes.
large quantum entities is a Bose-Einstein condensate,
Yes.
right?
Metamaterial,
A large object that still has this quantum coherence. It becomes a single entity,
Yeah.
right?
Yes.
And so that's another clue to the mechanism. How in the world is the vacuum manifesting these things, and how does it seem to have this non-local connectivity to itself? We're making
Yes.
large objects from the vacuum. And so there's more going on than individual particles. And
I would, in my crazy consternations around three-dimensional time, I've taken it one step further a little bit in terms of going to the subatomic levels with the same concept of quark plasmoids. In classical physics, shit's all over that, right? You can't deconfine quarks, and what the hell is spin in terms of quantum mechanics? Well, it's a character, it's a property, and Feynman had asked why. And you keep asking why, and then we suddenly realize, well, we don't understand quarks. We don't understand what quantum spin is. We don't understand entanglement. We don't understand a whole lot of really critical things.
And by the way, the Russians didn't jump on the quark model. You think about it, the quark model is somewhat contrived.
They can do it. They can do the quantum entanglement experiment, the spin from experiment. They can use it, but they don't understand. They don't understand what charge. Like Paul said, they don't understand what charge is. They just given it a name, so they can use experiments. They can do a certain amount. They know a few tricks in experiment, but they don't really understand it very well. But they just know a few
spot
tricks.
on, Brendan. Yeah, right on, nailed it stone cold. And it is a catastrophic failure of classical physics. It's baked into our whole model right now. We need to walk away from at the speed of light.
Yeah.
Faster than light. Oh, which is possible. Hate to say that. All right. Formation of charge clusters is typically associated with phenomena such as fractal emission. The cracking materials like crystals or dielectrics leads to the emission of these charged plasmoids. This process is akin to generation of earthquake lights, morpholights, or ball lightning, where similar plasmoid structures are observed. So they've seen those. Yeah. The potential application of charge clusters in UFO technologies is speculative, but intriguing. The idea is that these clusters could serve as means to tap into zero-point energy, providing a virtually limitless source of power for advanced propulsion systems. The interaction of charge clusters with ZPE could lead to the generation of high-energy outputs, which might be harnessed to achieve the seemingly impossible feats of speed and maneuverability often reported in UFO sightings. UFOs are frequently described as exhibiting behaviors that defy conventional physics, such as rapid acceleration, sudden changes in direction, and hovering without the visible means of propulsion. If charge clusters can indeed couple with a zero-point field, they could provide the energy necessary to power such advanced propulsion systems, potentially explaining some of the observed characteristics of the craft. Etherons and the ether. Next paragraph, the concept of the ether or ether, A versus E, has a long history of scientific thought, originally proposed as a medium through which light waves propagate. Although the classical notion of the ether was largely abandoned with the advent of Einstein's theory of relativity, modern interpretation suggests that the vacuum of space is not empty, but filled with fluctuating energy fields, often referred to as the ZPE. Etherons in this context could be considered as hypothetical particles or entities that exist within the ether, facilitating interactions between charged particles and the vacuum energy. These etherons might exhibit toroidal structures, similar to the vortex rings observed in charge clusters, allowing them to interact with EM fields, electromagnetic fields, and potentially serve as conduits for energy transfer. Going on to the next page. This is an important page. The entire thing is painted yellow. All right, to harness the energy of the ether using large clusters, one would need to create conditions that allow for the formation and stabilization of these clusters. This could involve, number one, creating plasma environments. By generating plasma through electrical discharges or other means, one can create the conditions necessary for charge cluster formation. The plasma provides the charged particles needed to form the clusters and the electromagnetic fields required to stabilize them. Utilizing fractal emission. Number two, by inducing fractal emission in materials such as through mechanical stress or electrical excitation, charged clusters can be generated. These clusters can then interact with the surrounding electromagnetic fields and potentially couple zero-point energy. Number three, designing toroidal structures. The toroidal shape of charged clusters is the key to their stability in interaction with the zero-point field. Designing devices that can create and maintain these toroidal structures could enhance their ability to tap into the ether. Number four, exploring resonant frequencies. Identifying the resonant frequencies at which charged clusters interact most effectively with the zero-point field could lead to more efficient energy extraction. This might involve tuning electromagnetic fields or the plasma environment to these frequencies. Conclusion, the study of charge clusters and their potential applications in UFO technologies and ether interactions is a field ripe with possibilities. While much of this remains speculative, the underlying principles of plasma physics, electromagnetism, and zero-point energy provide a foundation for further exploration. By understanding and harnessing in yellow these phenomena, we may unlock new sources of energy and propulsion that could revolutionize our understanding of physics and technology.
Wow.
Yeah, that's it. That's it. Okay, I'll just take that down. Okay, thanks, Chip.
Yeah, thank you. And Moray, thank you for commenting on some of that stuff too. it's nice to get it from the horse's mouth, basically.
I think
Took a
all of
lot of
those
notes today.
I think all those comments in there, those probability type statements may contribute or convert them all to will. Convert all the mays to will.
Yeah. Cool. So does anyone have comments and stuff?
So this is Ryan Wood's AI.
Yeah.
Ryan did a good job.
Yeah, carefully trained.
Yeah, there might be about 1 million documents in there now. I think when I did some of this stuff with him before, there was about 750,000 documents in there. And we've even actually fed him in our shows, like the transcript to these shows. In fact, maybe this number 37, which we just redid today, is already in there because I've sent him a bunch of different shows and whatnot, especially when we're talking about the Turing wave, because there wasn't that much information on the Turing wave in there. So we've actually added quite a bit of stuff. I probably should ask some more questions because it's always awesome to see what comes out of all this stuff.
Yeah, another thing to stress was the size of a Etheron, which was a postulate 10 to the minus 65. Right,
Yep.
anything down below the Planck lengths, when you get into quantum mechanics, this is we're washed out. We can't do any physics down there.
Yep.
And feeding that information to AI to see how it can handle it, because there's basically a contradiction on anything that's so tiny. Or even perhaps more important, there seems to be a bit of unfair game when people are postulating something that can't be measured. Like a quark's a great example. A string loop in string theory, which is down at the Planck length. Quark says, "Oh, you can never measure it because it could never come out of the nucleus." And anything real tiny, we can't measure it. Oh, the physicists or when they postulate that, they're saying, "Ha ha, you can never prove me wrong." Right, because there was no measurement you can make that says these things don't exist. Right, so I postulate they exist, and then I think when the entanglement stuff became seriously accepted, right, it took a while that the string theory evolved to a miracle particle, which in the probabilistic wave, it could be any size, and this little string loop could have magically expand to the size of a galaxy and collapse back again to give them the non-local mechanism. And I just rolled my eyes. You're just contriving stuff, right? And there's no experiment that you could ever do this. Oh, this magical particle exists. I can postulate that, and you can never prove me wrong. And so there's a phrase they do when you postulate things in physics, and you can't do an experiment to differentiate. I think the insult is not even wrong. There's some phrase they use that says you're so far out of bounds. Your theory can predict anything because what you postulated in can be manipulated to do anything, match anything you want.
Yeah.
And that was the big criticism of string theory. It kind of fell out of popularity when they really could just say these magical particles, I can make them do anything we want. Well, what about all the constants of the universe? Well, we have multiple universes, right? And all the constants and these strings can do anything and make the universe you want. Most of them wash out because you need a Goldilocks miracle to get everything balanced just right to even have existence.
Yep.
Right? Either everything collapses back down into nothing or blows up to it's gone after an instant. So all those universes are out, and it's the anthropic principle they end up using, which says, "Oh, you obviously live in one of those lucky universes, otherwise you wouldn't exist."
Right.
To be criticizing it. And so the anthropic principle came along where anything goes, and that's what the problem is doing. Anything goes, and you happen to be living in a lucky universe. And if you weren't living in a lucky universe, you wouldn't be living.
So the anthropic principle is the Big Bang. So the anthropic principle is that matter was created because we're here now observing it. So it must have been created at some point because we're here now. So therefore, it must have come from the Big Bang or wherever it was that it came from. It must have originated at some point. because we're here now. So it must have, because we're here now and we can observe the universe. The universe must have been created.
Yeah, and then the multiverse, and what's nice about the multi worlds many worlds
Some
interpretation.
physicists hate the anthropic principle. Like when I was doing thermodynamic classical physics, guy who's a similar age to me is teaching a BSc classical physics and also thermonuclear physics. I mentioned the anthropic principle. He said he hated the anthropic principle.
Right.
He kind of
and most engineers agree, right? Engineers especially, you can't. Everything has to be local model explained. So anytime you avoid that and just go into okay, anything goes. Right, I say the engineering community hates it. Now the philosophical community that does many worlds and likes psychic things occurring like spoon bending, or maybe an inventor can make an energy machine work with his mind, but nobody else can, like Lester Hendershot and things like that. Then you get into the whole psychic consciousness world that the engineers they hate that. They want engineerable systems. They don't want to believe it. That's why they don't believe in 0 point energy. They want everything to work classically.
Yeah.
Nice local is everything, locality, local causality, and that was common sense. Really, we really came off of that, and all of us back when relativity was accepted, right? Space time is rubbery, right? The pace of time can change everything else. And then you get into quantum mechanics, well, hell broke loose. What we're with the non-local stuff. And Einstein, Rosen, and Podolsky were quick to jump on it. 5 years later, they published their famous EPR, very graciously say quantum mechanics must be incomplete. When they were just saying, wrong. It's predicting absurd things, non-localness, right? And they were quick to point out.
Two particles, like the Alan Aspects experiment, two particles, electrons, about 14 meters away from each other. If they measure one spin up, the other one must be spin down. So they said it seemed to be communicating instantaneously. That's where hidden variables, Bell's inequalities was the hidden variables, and then he disproved Bell's hidden variables and vindicated quantum mechanics because it's non-local means it communicates instantaneously, and nothing can travel. The Einstein Podolsky Rosen was that nothing could travel faster than the speed of light. So there must be unless it's non-local, then it communicate instantaneously. But that's nothing to do with the speed of light. That's just quantum weirdness.
Oh, right. And now let me tell you, in the standard physics literature, there's a popular theme of research, theoretical research, and its nickname is ER equals EPR. Is the nickname. ER is Einstein Rosen, EPR is Einstein Podolsky
Rosen bridge.
Einstein Rosen bridge is a wormhole, right? And EPR was non-localness, and that nickname refers to I'm going to explain non-localness with a wormhole, basically. That connects things outside of a 3D universe, right? So it's like science fiction, but you notice it's an attempt in the mindset. I gotta make local causality somehow, right? So I make a bridge. And now I have a causality model that I can understand. See how we're picturing things, and we have particles in existence.
That was Einstein thought that quantum mechanics was just a temporary theory until they understood. He thought that he said God didn't play dice, and he thought quantum mechanics was just like a temporary thing until they understood what was going on. But he didn't like quantum mechanics.
And it's thinking like with common sense. Right. When you think about it, all your differential equations that we've used to do the foundation of science and the foundation of physics involve derivatives with space and time, right? And if you have this quantum foam thing in existence, you just washed out the metric, which is how you do derivatives. You don't have flatness anymore to even do an approximation on the calculation. So it was really rejected, basically. They don't know what to do, so they're told shut up and calculate. This seems to work.
I think that
don't try to picture it. Don't try to explain it.
All would you say that's the Copenhagen interpretation? It's a complicated philosophy which stopped people from looking deeper than quantum, which basically means shut up and don't ask shut up
Yes.
and don't ask questions. That's the
And of
Copenhagen.
course,
That's
right.
a summary
That's
of the Copenhagen
the first
interpretation.
interpretation. So
Complicated
Yeah.
philosophy.
we can
Complicated,
avoid thinking. Yeah, that was
complicated
basically.
philosophy. The Copenhagen
And
interpretation is a complicated, very complicated philosophy, which basically means shut up and don't ask questions.
you know, you guys were talking about
That's not doing science, right?
the non-local. That is basically time space, and it's actually, if you think about it, it's the etherons that are doing the work of drawing this information, energy and information from time space to space time where we are essentially, right?
And basically we're now willing. Now physics is most very willing to go into higher physical dimensions, right? So when you talk about time space, it's just another model of higher physical dimensions. And so that community was very willing to add some dimensions, Klein-Kaluza models and things like that at will, all right? And where the engineers just hate that. They
Yeah.
just want common sense. Our spaces are common sense locality. They want classical physics.
That's the problem.
Because at least we understand that. As soon as we get into the weirdness of quantum thing, the whole thing washed out.
Yeah.
Many worlds is fun. I like that. And then a lot of the stuff you can tie in once you have these higher dimensionality. You only need one extra dimension to practically get
That's
into.
right.
The Copenhagen interpretation was basically designed by Bohr, Niels Bohr, who's the main guy designing it. And it's basically a very complicated philosophy, which basically tried to bar anyone from looking deeper than quantum mechanics, because they start up when they try to understand quantum mechanics with English, the language, Western language. They was just or English main. It's up was down, left was right, a circle is a square. It just made, like Bohm said, it just made a mockery of language. That's why David Bohm was trying to look for Rio a verb-based language that they could use, that they could speak, that would enable them to understand quantum theory, because quantum theory just made a mockery of language. So they could follow the mathematics. They couldn't understand it. They could follow the mathematics, and you can understand it intuitively when you get good at it. But they just followed the mathematics because they couldn't understand it logically. So they just they could just follow the mathematics.
It made a mockery out of our perception of our world of three dimensions of space and the uniform pace of time. It made a mockery out of that. In fact, Einstein started in 1905, so that can start to be rubbery. The mockery is non-localness.
Yeah.
Now something else is going on, right? Implying higher dimensions.
Bohr was the one that quipped the quote, "Shut up and calculate," right? Was that Bohr? Or?
I don't know.
I know he implied it.
I think I don't know what you can look up on ChatGPT or whatever.
Yeah,
where that came from. I think from what I mean, I think I know that was what Bohm was saying. But they were telling Bohm was talking about the fact that it was shut up and don't ask questions, is what he was getting. And I made the link back to the Copenhagen interpretation, which is basically very complicated philosophy, which tried to stop people from looking deeper than quantum mechanics. And so if you summarize, just shut up and don't ask questions, just calculate.
So I asked
it was Bohr.
AI. I asked AI the deep question, and it responded, "Shut up."
Yeah, it's not in classical physics, so it can't be right. Yeah, I would offer this.
So then Bohm was gone. Bohm was basically, he tried to develop Rio mode because he was in the same class as David Bohm was in the same class as what's his name?
Dirac, maybe.
No, not Dirac. He was, he knew Dirac, but I mean, same class as Richard Feynman, and Oppenheimer was his teacher. And he basically, one of the things he was doing in Wholeness and Integral Order, psychology, philosophy, and physics, he was said where they were setting out that he wanted to try and develop a language which he called Rio mode. And he thought it's impossible. You can't create a language. It just happens naturally. You can't create a language. Like Esperanto was the European language they were trying to do. You can't really create a language. And then when he visited the Blackfoot tribe in Canada towards the end of a few years before the end of his life, they were speaking a language where he thought was very close to Rio mode, a verb-based language. Like their language was like wind. The wind is the sound of leaves. The sound of the word for wind is the sound the leaves make when it blows. Or fishes are processes in the water. And he thought the Blackfoot tribe and Native Americans were speaking a language very close to Rio mode. So he thought that they might
That's
be able to
interesting.
develop idiomatic order and all that and things like that.
Cool.
Did not
Cool.
know that.
Yeah, interesting stuff. Should we
Wow.
stop the recording at some point here, you guys, or do you guys
Yep.
want to?
Yeah, we're edging off the rails here.
Yeah, exactly. So
Well, of
yeah.
course.
We're
That's why I
supposed to be.
come to
That's the
that's why I
fun
come to
part.
this group.
Exactly.
Rails, what rails?
That's exactly right, Murray. I love it.
Yeah, I had a question along those lines, Maury.
Yeah.
In your study of the literature and stuff, why is it there is so much pushback on the acknowledgement of the 0 point energy field? I mean, it has been demonstrated for the last 100 years, off and on, with some really good experiments, and yet the engineers, we'll leave them out of the picture for now because this doesn't work with their engineering models or anything else. Why is it these academicians push back so hard on that? And yeah, there's ego involved in their entire 60-year career in academics and teaching physics, all that's involved. But why in the hell did you can't get even an instinctive positive comment out of some of these people? What's your insight on it?
I lived through it at the
I know.
university. Yeah, and so I can certainly tell you this that academicians, scientists, okay, how many even have heard that the 0 point energy exists? Very small percentage, if they're not in graduate physics. Even undergraduate physics students aren't taught until you get to graduate school that it exists when you study quantum electrodynamics in detail in the textbook, things like that. Therefore, what is taught? I was there as an engineer. It was pretty clear what was taught. It was pretty straightforward. You're taught that the ether does not exist.
Yeah, there it is.
Einstein threw it out in 1905. You have some rubbery space-time and special relativity, and that to me that paradigm shift was just amazing to the classical scientific community, because when they accepted that, they threw out the common sense notion of our observed reality, 3 dimensions of space and a uniform pace of time, right? And at the time that it was amazingly accepted by a huge number of scientists back in 1905. And what was so compelling about that they're willing to throw away common sense? What was it that special relativity did? And now this was Einstein's contribution. And I was amazed when I learned what that was when I was sophomore fields as undergraduate engineering, right? Sophomore level field. It was right in the textbook, fields theory. And I did the calculation. So do you know what it was that caused the paradigm shift to be so well accepted? Giving up common sense. Of the nature of space and time, which is a foundation of taking all our derivatives and writing differential equations, all the math of classical physics. All of a sudden, you're monkeying around with the foundation.
And
do you know the answer? I know the answer because it was right there in my textbook, and I was astounded. And I recompare. So can you guys guess, and then I'll tell you the answer.
You see, I got Dewey's book.
That takes us. Boy, does that take us off the deep end, right where you live, Chip.
I think I think there's probably a chirality problem. I think you guys have seen it ass backwards.
Is that Maury's book? Maury, is that your book?
No, that's Dewey Larson's book.
That's Dewey Larson's
book. Do not read that book till after you give your presentation at our science party, because I don't want you to be contaminated by Dewey. You have your own 3D time and 3D space, and I want to hear your ideas pre-contaminated, because that was a Dewey Larson crowd you were addressing at that conference. So you diverted me up from my rant here on what was it in science. So I think the answer is no, nobody knows, and I the answer, and I think scientists in physics would know. What was it that made relativity accepted? He unified the electric field with the magnetic field.
Right.
And back in Maxwell's equations, they were
I,
separate.
I was about to say that because right at 1905, that's when Maxwell's equations got messed with, basically big time, right? So that was all in the same time period, kind of, right?
So you have Maxwell, they're dealing with the classical ether, right? Trying to
Yeah.
explain, so the magnetic field was a vortex action of the electric field, and all these ideas. The vocabulary was fluid theory, that's for electromagnetism, flux, vortex. Yeah, all those ideas are from fluid theory, and that's what the
Yeah.
popular ether model was. And he had to deal with other issues of stiffness. There was contradictions. It made a very complicated ether, but it could exist even with special relativity. It was a highly, highly complex ether. So what it was astounding. And this is the part that caused me to go through the textbook calculation 3 times. And by the way, you can get YouTubes that'll go right through that calculation these days for you. And that was that the magnetic field is the Lorentz contraction of the electric field.
Mm.
And it's astounding at low velocities. That's the part that knocked my socks off, because when I first learned about relativity and everything else, I thought, oh, you got to be up near the speed of light to have any effects occurring. And so for the most
Yeah.
part, you're just simply classical. But even at slow velocities and the drift velocity, this is the part that blew my mind. The drift velocity of an electron in a wire for a standard current to produce like a house current at that
Yeah.
level, to produce the measurable magnetic field. The drift velocity, that also amazed me when I learned that. Uh, a couple feet per hour.
Yeah, exactly. It's
Hour.
super slow. Yeah.
Super slow. And yet that super slow velocity, you put it into the Lorentz transformation, you do the calculation perfectly for a particle moving at that super slow velocity would have a Lorentz contraction effect. Right. The v squared over c squared, that's practically zero. But that tiny, tiny little small number was perfect in the calculation to match the magnetic field that's observed in just normal everyday currents.
Hmm.
And the perfection of that calculation at tiny, slow velocities um, made the consistency of electromagnetic field, and it was compelling. It was amazingly compelling. And what it also shows that the electric field is so powerful, right? That because its exponent is way above the energy density of the magnetic field, that nonetheless, it's perfectly balanced in the wire, so you have really no appreciable net charge. That's
Hmm.
a neutral system. And they said it's relativistic. If I do the calculation pretending I'm moving with the electrons, they say, oh, the lattice is moving the other way at this tiny, tiny slow speed. And so you do the calculation from the other point of view, which is what relativity is all about. It
Yeah.
was still perfect. The perfect calculate the other type of charge. I was astounded, right? When I learned that. So here I am learning. You mean relativity works at a tiny, tiny little velocity, and it
Hmm.
produces a big effect?
Yeah.
And they were right. It's explained because the relative strength between the actual raw electric field is so much huger by 10 to the whatever huge exponent and the only reason it works, we don't see the electric field. It got perfectly balanced out between the electrons and the lattice protons or lattice. It was perfectly balanced out, and so you're only left with this residue of the magnetic field. At the last Tesla conference, they interviewed me, and they were amazed on the interview because they didn't know any of this. You have to take some physics, undergraduate physics, to even go through that to know that.
But
Yeah.
And so, what's amazing is how whatever, the attitude. Oh yeah, math works perfectly. Isn't that wonderful? And that's why relativity was accepted. And Einstein said, well, at least if we keep everything under the speed of light, we still have local causality. That was the important thing. So you still have some common sense. So that means if something over here is going to affect something over here, something has to propagate over and kick it, right?
Mm-hmm.
Right. And so that's why if I'm below the speed of light now, I can let light be the thing that propagates over and interacts with.
By the way,
so I still have.
Bone was saying that you could understand the implicit order through poetry and music. Not through logic. Well, he was unless they developed this rear mode thing. He said basically you could understand the implicit order through poetry and music. You could glimpse it.
And meditation, I might add.
Yeah.
And if you do it right, you'll be just like Chip.
Coherence, right, guys? Yeah. Cool. All right. So maybe we could shut the recording off, and we'll thank you, Moray, for that. Yeah, that was amazing.
We got to stop this ranting before we get into consciousness.
Yeah.
Shut that recording off.
Wait a minute, I was going to start that conversation.
I know, because it's a legitimate conversation. As soon as we got into quantum non-localness.
Yep.
Here's a little nugget. Here's a little nugget I went back and found in my notes from the J Collective. All right, so time is flowing color. And color is a part of the ether vacuum. Comes out of the vacuum.
Frequencies.
That's what I equated it to, Ed, and I wasn't quite sure that was it. But think about it for a minute, because now it's a classic tidbit thing you get from these guides. They want us to think about it. They never tell you the whole damn answer. They always want you to, kick it around in a group and figure out what it means. I'm just going to leave it because I'm not sure what it means. We'll discuss it next week.
It's colorless black or white. So it's colorless black or white. Without white light, you can't see color. So without light is black. So is black colors or is white colors? If you've got white light, you can see color. If you've got no light, it's just black.
It's interesting because when you looked at the Check-Paranoff generator with the black and white EVOs.
I was about to say that, yeah.
That's what I equated it to. I said, okay, because I saw the black EVO as a three-dimensional temporal anomaly. And I think Chris Beskar was trying to get to say the same thing. And so here the J come along and say, oh, guys, take a look at this. Time is really flowing color. And so that equates temporal anomalies with the black and white thing that Brendan just mentioned.
Yeah.
Okay.
Yeah.
Okay. Whoa.
Very, very cool.
White light has all the colors of the in physics. But white light has all the colors of the spectrum inside it. That's like
everything.
When Newton put white light through the pyramid, it split up into the colors. Do you remember the
prism through the prism?
The glass prism. He put white light shone through the glass prism. It split up into all the colors. Anyway, so.
Yeah. Absolutely.
White contains all the colors anyway. Okay.
Okay. So let's shut the recording off before we go off the rails.
Okay.
Exactly. Hurry up,
Come on. Hope you have a wonderful rest of the day. Cheers.
We're gonna have black SUVs at our doorstep tomorrow if we don't shut this recording.
Bye everyone.